Here we go, pre-cal. All right, we are going to talk about 3.3. So this is 3.3, Unit 3, Section 3, Graphing Rational Functions. So all of the stuff we've learned how to do so far, like find the asymptotes and find the holes in a graph and all of that stuff, that is all coming together now. We needed to know how to do all that so we could, in fact, learn to graph them. So we are going to graph these rational functions and identify all of the information to make it easier to graph. So I'm going to start, of course, by the very first thing we always want to do is factor everything that can be factored. So that is the first thing we're going to do. So I am going to factor the numerator, and the denominator is already factored. So remember, once I factor, then the next thing I do, my first step is factor, my next step is to define the domain. So I am going to do that. That's right down here. And I didn't leave a lot of room. I should have done that, but all of x such that x cannot be equal to 3 or -1. And it contains a set of real numbers. There we go. Okay, so now we are going to reduce this. And our final equation, or our final function, is going to be this right here. So now we answer all of this other stuff. So the vertical asymptote is x equals -1. The horizontal asymptote, remember we look at the degree. The degree for both of these is 1. So my horizontal asymptote is the leading coefficient ratio. Since that's 1x and 1x, it would be 1. And of course, since there's a horizontal asymptote, there is not a slant asymptote. And to find my x-intercepts, remember I set my numerator equal to 0. So I have an x-intercept at -3, 0. My y-intercept, I am just going to let all the x's be zeros. So I'm going to have 0 squared. Oops. Forgot what I was doing. I'm going to have 0 plus 3 over 0 plus 1, and that gives me 3. So my y-intercept, of course, is 0, 3. There is going to be a hole where x is 3 because the x minus 3 and x minus 3 reduced or canceled out. So now I'm going to use my reduced function, and then I'm going to substitute in the 3 here and here to get my y value. So that's going to be 6 over 4. And it'll be easier to graph if you reduce it. So 6 over 4 just becomes 3/2, and there's the hole right there. All right, the range and the graph behavior and increasing and decreasing, that's going to be easier to do after we graph it. So we are going to jump over to our graph here, and we are going to graph what we're seeing here. So I'm going to start with my vertical asymptote. It's x equals -1. So it's going to look just like that. And then my horizontal asymptote is at y equals 1. So it's going to look just like that. And then I'm going to go to my intercepts and the holes because those are going to guide my graph. So if I've got an x-intercept at -3, 0, that's going to be right there. That is an indicator that my graph is going to live in this quadrant right here. That's what that means. So it's basically going to do something like this. All of these graphs behave this way. They hug the asymptotes. That's how they work. Okay, now I'm going to look at my y-intercept. It's 0, 3. So that's right there. And then, of course, there's a hole at 3 3/2. So I go over 3 and then up 1 and a half. That's 3/2. So there's going to be a hole right there. So then my graph is going to look something like this. All right, it's just going to hug that asymptote all the way in both directions. So that's what my graph would look like. Okay, now I can define my range. Remember, my range are my y values. So I'm going to start at the bottom and go up. So I've got this arrow coming down here indicates that all of the negative values are covered. So for my range, I'm going to have negative infinity up to, well, my graph is right here, but there's no value at the 1. So it's going to go up to the 1. And then you'll notice we've got some space right here. See where the hole is? The graph comes down right here. So there are some values below 3/2 right next to this asymptote at 1 right here. So I am going to choose 1 to 3/2 and then 3/2 on to positive infinity. So the range is a little challenging. You're going to struggle with that just a little bit. Okay, now we're going to look at the graph behavior. We have 2 types of behavior. I'm going to switch pens here, switch colors so you can see this. All right, we have 2 things happening. This right here is end behavior, and so is this. Remember, with end behavior, as x always approaches infinity and x always approaches negative infinity. Well, as x approaches positive infinity, y is going to approach 1. And as x approaches negative infinity, it's also going to approach 1. All right, so I need to switch pen colors again because we need to look at the asymptotic behavior. Notice you're asked about the vertical asymptote behavior. That color's not different enough. Let's pick pink. Okay, so vertical asymptote here. So that is going to occur right here. Vertical asymptote, vertical asymptote. Now we have to be careful about this behavior. We are going to still start with x for both of them, but you have to pay attention. The x asymptote is this -1 right here. So as I approach from the right, x is approaching -1. But also down here in this part of the graph, it's approaching -1 there as well. So we have to indicate from which direction it's coming. So x is approaching -1 from the positive direction over here, and y in response to it is approaching positive infinity. So I have to indicate above the 1 that it's approaching from the positive direction. So approaching from the positive direction. And then over here on the left, x is approaching -1 from the negative direction, and y is responding by approaching negative infinity. Okay, so I know it's a little stressful. You'll be okay. Now we're going to look at increasing over what interval and decreasing over what interval. Well, if you'll look, as I'm looking at this graph right here, as I approach from the left, it is decreasing. As I come up here and approach this, as I'm moving to the right, remember increasing and decreasing is from left to right. So from left to right, this is also decreasing. So it is decreasing over an interval of negative infinity. Remember, we always use our x values. We are decreasing from negative infinity to -1. And we are also decreasing from -1 to positive infinity. We are not increasing at all. Okay, I know that's stressful. I know it's a lot of information, but we're going to do 2 more examples in the next videos.